Welcome. In this video, we are going to solve this question. If the Earth suddenly shrinks to half its present radius, what will be the duration of the day in that case? What does it mean? It means if Earth shrinks to half its radius, if this is the radius and it is half, if it shrinks to half its radius, that means it becomes of this size. What will be the duration of day? Earlier, the duration of day will be the one time period, that is 24 hour. So what will be the duration? Whether it will increase or decrease, how much it will increase or decrease. Now the thing here is the forces involved here in shrinking its radius to half are internal forces. So torque will also be the internal torque. So you can say external torque will be zero. So what is law of conservation of angular momentum? Or you can say the relation between angular momentum and torque, that is net external torque equal to rate of change of angular momentum. So torque is tau. We will write ext, that is external torque, and net means vector sum of all torque applied. It will be equal to rate of change of, that means the differentiation of angular momentum with respect to time. Now the forces involved here are internal. That means net external torque, or that is the left hand side of this equation, is 0. So right hand side will also be 0. That means the dj over dt will also be 0, or you can say j will be a constant vector. Means what is j? J is the angular momentum. So angular momentum will remain or will conserve its magnitude as well as its direction. You can say it is the law of conservation of angular momentum. Or you can say j will be constant or conserved. Conserved means the event here is shrinking. So the angular momentum before shrinking will be the angular momentum after shrinking. So angular momentum before shrinking will be equal to angular momentum after shrinking. So angular momentum before shrinking will be equal to angular momentum after shrinking. What is angular momentum? J is equal to I omega. So I omega means I1 omega 1 will be equal to I2 omega 2. What is I? I is the moment of inertia and omega is the angular frequency. What is moment of inertia? So considering this, Earth as solid sphere. So I we will take 2 by 5 mr square. In the first case, it is I1. So I1 will be 2 by 5 mr1 square. I have not written m1, m2 because the mass remains unchanged. In the second case, after shrinking, I2 will be equal to 2 by 5 mr2 square. But it is given that it is shrink to half its present radius. That means R2 will be equal to R1 by 2. Substituting this into this equation, so I2 will be equal to 2 by 5 mr1 by 2 square. So it will be equal to 2 to the 4. That means you can say 1 upon 4 2 by 5 mr1 square, or you can say it is equal to I1 by 4. So I2 will be equal to I1 by 4. What is omega 1 and omega 2? We know that time period of the rotation of the Earth that is T1 equal to 24 hour. You can say the duration of the day is 24 hour. So omega 1 will be equal to 2 pi by 24 hour minus 1. The omega 2 will be equal to 2 pi by T2. T2 is the time period after sinking, or you can say the duration of the day after sinking. So T2 is the time period after shrinking. So we will substitute these value into this equation I1 omega 1 equal to I2 omega 2. What is I1? So I1 we will write I1 omega 1 is 2 pi by 24 equal to I2. I2 here is I1 by 4. That means I1 by 4. What is omega 2? Omega 2 is 2 pi by T2. Now this 2 pi cancels out. 2 pi cancels with 2 pi. This I1 cancels with I1. What is T2? We will take this T2 to left side. So T2 will be equal to 24 taken out here. 24 upon 4 equal to 6. Or you can say T2 equal to 6 hour. So the duration of the day after sinking will be 6 hour. You can say the time period of the earth after sinking will be 6 hour. It will be reduced to 6 hour from 24 hour. The PDF copy of the notes of this video can be found in the description below. Thank you.